So direct variation is something you already are familiar with as what we call proportionality. And we can use this symbol to signify that y is proportionate with x, or that y varies directly with x. What we're used to seeing is something like this. So these ways of writing it means the same thing. From the examples we know, the x is to the power of 1. But we can generalize this and say that direct variation is whenever we have a constant k multiplied with an x to the power of n, so any number. Well, n is a part of the set of integers. Yeah. A simple example would be pay. If you pay, if you work 0 hours, you get 0 money. If you work 1 hour, you get 100 kroner. If you work for 2 hours, you get 200 kroner. So the pay is directly proportionate, or it varies directly with the number of hours. So y here would be the money you get, and x is the number of hours you work. And k is simply the number that you have to multiply x with to get y. So in this case, y equals 100x. So we multiply 1 with 100 to get 100. We multiply x with 200 to get 200. So, and we could also write this as a function. Say that y is called the function f, and f is a function of x, where f of x equals 100x. So in this case, k is equal to 100. Now we'll look at an example where we have, this is example 14 in the book, where you have a rock that falls. So it falls from a height. And the distance in meters varies directly with the square of the time taken. So this is how we would write it. So the d here is the distance, and we measure that in meters. And it's in direct variation with this variable t, the time. And time is squared, so we're told that the distance varies with the time. So the square of the time is multiplied with a constant k, and we don't know what that is yet. So let's start solving this problem. Now the distance is t, and we can write the distance as a function of t. So this is our distance function, and for now we can just write k multiplied with t to the power of 2. This is what we know. Now, to answer question A, we're given a piece of information. If the rock falls 6 meters in 2 seconds, write an equation for D in terms of T. So, we're told that a rock falls for 2 seconds, so we're looking for D of T equals 2. And we know that the function value is then going to be 6. It falls 6 meters in 2 seconds. So now we have this function, this equation, where we know that this is equal to 6. And, we also know the time. It's 2 seconds to the power of 2 equals 6. So we want to find k. And if we multiply with 4 on both sides, we find that k is 6 divided by 4, which is 1.5. So our answer to question A would be that T equals 1.5 t squared. We could also write this as a fraction. That makes things easier. This is the same answer. Now, question B. Find the distance the rock has fallen after 5 seconds. And now we can use the equation we found and say, okay, so the rock is falling for 5 seconds. What is the distance going to be? So we have 3 halves multiplied with 5 to the power of 2, which is 3 halves multiplied with 25, and this is going to be 37.5 meters.